Hello everyone, I am Robin. Today I'll show you a demo on 4-probe electrical characterization system. So it consists of first a cascade 4-probe setup, which is seen here, and this is connected to a Keithley SCS 4200 parameter analyzer. So it's this one. So first let us discuss about the probe station. So in this probe station we have 4 probers. So this is named as 1 prober 1, prober 2, this one is prober 3 and this one is prober 4. And these, or you can say them as actually micro manipulators. So in this we can adjust the movement of this micro manipulators. These are further connected to these probes here, like you can see here. This is connected to further a probe, and these can be moved by using these knobs. This is for Z movement, and this knob is for XY movement. So for first step during your device characterization is to put the sample on this chuck. So this is a gold plated chuck. When you're putting the samples, you should keep this knob down, put your sample here in this center portion. So this is used to hold your sample. So this is further connected to a small vacuum pump which holds your sample. First you should keep your sample here, then here is one knob, chuck on, off. Then if you put it up, then it will hold down your sample. And then you should turn it off when you want to remove. So the first step, as I said, you should keep your sample here, put the chuck on button, and then do the probing. So how you have to do is, what you have to do is basically put your sample and then bring this micro manipulators probe close to the center. So you should not slide this micro manipulators, like you should not push that, means slide on this surface, otherwise it will scratch the surface. So you should always pull it up like this one, and wherever you want to place, like suppose I want this tip to go to the center, I will put this tip to the center and then place this like this way. You should not slide. Additionally, we have one knob here. If you put this knob this side, and then it will hold down this micro manipulator to the chuck by using magnetic forces. So now I will not be able to move this one. So if I want to move it, then again I have to put this knob this side, and then I can move this prober and this micro manipulator anywhere. So next step is, if you just put a sample here, then use this knobs to adjust the X, Y and Z and bring your probe to the close to the chuck. Then you can always adjust, we have a microscope here, and you can adjust this and see your sample on a software which is available in this controller. So here we have one software named TS View. If you open it, we'll get a window like this, and I will double click it to have a full view of this image. Then we have a camera controller here. So this knob is for controlling the light. You can see by controlling this knob, moving this knob, I can turn on the light from here. Additionally, we have one extra switch here, this one. This is used to turn on or off the light. So first it should be on, then we can adjust the intensity using this knob. Okay, so by turning on the light, then you can see your sample in the camera. So then when you see this image on this camera, on this monitor, then you can focus your sample. So for focusing, you need to adjust the knobs from here of this camera. So there are, this one is first, this has a camera movement. With this you can focus. One knob is this one, second is this one. So using these two knobs, you can focus on your sample. Then here we have two eyepiece also. This is, as you can see, it is 20x, and additionally we have a 3 megapixel camera here. Okay, so there are two ways to see your sample. First is using this camera. So this camera will feedback your image directly to the screen, which is shown in this TSV software. And the second option is, here we have a knob on the back side. As you can see here, so currently this knob is pointed out. So out means you are seeing by the camera. So if you put this knob in, then it will see by the eye. That means you have to see your sample using these objectives and not by this camera. So now you can't see the image on the camera. So you can do both ways. Well, I prefer to do normally on this camera. So eyepiece will be used when you are focusing on very small samples. So normally we keep it in this way and we see the samples on the camera using the TSV software. Okay, so when you place your sample, then you on this check on button, your sample is held properly. Then you should up this knob, and then you should focus using this and see the image on the camera. And then you should use your micro manipulators to connect the probes, like this probe connected here to your sample or whatever the metal contact you have made or pad. But so when you're putting this probe down, so the probe will go this like this from in Z, it will go from up to down. When it slightly touches your sample, the tip and the shadow, like here you can see. Now I am just demonstrating by using my finger that this is my finger and below is the shadow. Similar is the case for a probe. When the probe is coming down, at one point the shadow and the probe will get connected, and this is for silicon samples. For glass lights it may not be the case. So you have to carefully and slowly move down the Z from this knob, this one. So here it is mentioned that in this direction it is up, so it goes up in this direction and goes down in this direction. Similar is the case for X and Y. It is mentioned here where to go in this which direction. And then when you are moving the probe down, then it will meet the shadow, or when it touches the sample, you have to move slowly and just slightly push it to make sure that it is connected, and you should not push it too hard or too much, otherwise the probe tip may get damaged or your sample may get damaged. So slowly move the probe bottom. When it is connected to the sample, stop there. Okay, now your connections are made. And one more tip I want to give you here is that here when we are connecting the probe, I'll show you. We have different probes here. Right now we are using 7 micron probes. So we have different probes here. So you can place the probe in this holder, and then you can, let me pull it down, then you can rotate this knob from here, so it will hold your probe tightly. Okay, one is this case. So in this case, when you are putting the probe down to your sample, it will exert pressure on your probe, and your sample or the probe may get damaged. So one way one is this way, other is that you can try with losing this knob. You can loosen this knob here, and then you can push the probe little bit to the back. And now when you will move the probe down, when it touches your sample, the probe will automatically move like this. Like earlier your probe was here, and when it will touch, it will automatically move little bit up. So it will not exert pressure on the much pressure on the probe or your sample. Simply it will make the contact, and your probe life will be sustained. But in the other case, if you hold the probe tightly this way, in this one, then if you exert extra pressure or extra Z movement, then it may damage the probe or the sample. So this is one tip I want you to use, that you should lose this probe here and then use and connect to your sample. So this is about the probe station. One thing I forgot to tell you, that here we have different probes. Like we have a biax cable here, this one black colored, and this is the triax cable. So this is used for low current measurements, like this triax cable. So this is normally we prefer to use for low current, like below nanoamperes range, and this can be used there. And suppose if you want to do some high current measurements, or say high frequency measurements, like CV measurements, then you should use these cables. These are biax cables, or we can say this is further connected to BNC connectors or BNC cables. So for low current measurements, you should use this one, the silver cables, which are triax cables, and for high current or CV measurements, you should use these black cables, which are biax cables. So this is further connected. This is prober 1. This is further connected to SMU1. So here is our SMU1. This is SMU2. This is SMU3. So SMU1, 2, and 3 are source measuring units of the parameter analyzer. Here there are 3 preamplifiers. So this is one preamplifier connected to SMU1, one to SMU2, one is SMU3. So 3 preamplifiers connected to the 3 source measuring units. And then we have this. This is the black cable. Then we have red cables. These are for CV measurements. So there are 4 cables: CVH, CVU, HCUR. That means CVU high current. So this is a CV card actually. We have 4 source measuring units here, which are used for IV measurements, or let's say low frequency CV measurements. These CV measurements. And for high frequency CV measurement, we have CV card. So this is CVU high current, high potential, 2 probes. Then CVU low current and low potential. So 4 probes are connected this way. 4 cables. These are red cables. So CVU high current and high potential are together connected to one connector. Like I'll show you here. So this is one connector. So CVU high current and high potential are connected further together to a cable. So this cable goes to the prober. So in this case, we have connected this prober 1 micromanipulator 1 to this connector, which is connected further to CV current and potential, CVUH current, high current and high potential. And similarly, this prober is further connected to CVU low current and low potential. So for CV measurements, you have to use these 2 probes. And then this is SMU2, this one, and this is SMU3. So these 2 are connected to SMU2 and 3. So prober 2 is connected further, like you can see here, is SMU2 and SMU3. So right now SMU1 is empty. So suppose you want to do 4-point measurements or 4 probe measurements, for let's say you want to characterize a transistor, then you should do one thing, that you should connect this prober 1 wire. From there you should open this connector from here and connect this connector to this SMU1 preamplifier. Okay, then you can use SMU1, 2 and 3, and 4th one will be your ground. So ground is connected from here. So this is ground force. So this we have connected to chuck. So this and here. This is also grounded. Common ground is given from to parameter analyzer and this parameter analyzer and the probe station. Okay,